Welcome to my projectbazaar.com. Let us discuss about the joint clustering and routing design for reliable and efficient data collection in large-scale wireless sensor networks. Let us discuss about the abstract of the product. For data collection in large-scale wireless sensor networks, dynamic clustering provides a scalable and energy-efficient solution which use cluster heads rotation and cluster range assignment algorithm to balance the energy consumption. So moreover, most engineering work consider the clustering and routing as two isolated issues which is harmful to the connectivity and the energy efficiency of the network. In this paper, we provide a detailed analysis on the relationship between clustering and routing, and then propose a joint clustering and routing, that is a JCR protocol for reliable and efficient data collection in large-scale wireless sensor network. So the JCR adapts the back-off timer and gradient routing to generate connected and efficient intercluster topology with the constraint of maximum transmission range. So the relation between the clustering and routing in JCR are further exploited by the theoretical analysis and also a numerical analysis. So the results show that the multiple hop routing in JCR may lead to the unbalanced cluster head selection. So then the solution is provided to optimize the network lifetime by considering the gradient of one hop neighbor nodes in the setting of backup timer. So the theoretical analysis and simulation results prove the connectivity and efficiency of the network topology generated by the JCR. So here the proposed work presents and joint clustering and routing protocol for reliable and efficient data collection. So that is a JCR is adapted to the backup timer on the joint clustering and routing design for reliable and efficient data collection in large-scale wireless sensor networks. So the results show that joint clustering and routing may lead the unbalanced cluster head selection. So the theoretical and the simulation results prove the connectivity and efficiency of the network topology generated by the JCR. Let us discuss about the flow diagram of the product. So first of all, the first is node and base station deployment. So in this node and base station deployment, so the dynamic clustering provides a promising solution for data collection in large-scale wireless sensor networks. Sensor nodes are grouped into clusters which have a leader called a cluster head. So and the number of cluster members, so the data are first collected by the each cluster head from its clusters and then forward to the sink through the multi-hops routing. Moreover, the cluster head based topology is reorganized periodically in order to balance the heavy traffic loads of cluster heads. Due to the advantage of the scalability and energy efficiency, dynamic clustering has attracted considerable attention for different resource communities and has been implemented in various applications. However, most previous work deal with the dynamic clustering without in-depth consideration on the impact of intercluster routing. We argue there are light relations between the clustering and routing that may influence the performance of the data collections in large-scale WSN. So that is the energy efficiency and the network connectivity. So then implementing the JCR algorithm, that is a joint clustering routing algorithm. So the cluster head selection, by using the JCR algorithm we select the cluster head and the routing path design. So comparison of cluster heads and joint routing path design, so lead to the unbalanced cluster head selection. So that is a yes. So achieve the maximum network lifetime. If yes, the performance analysis is designed. If is no, now again the JCR algorithm is present. So in this JCR algorithm, the network modeling consists of a set of nodes and a sink deployed in a sensing area. We assume that the sensor network has the following properties. The mission of the sensor network is to collect the sensing data from sensor node to the sink, such that the destination for every sensing data in the sink. So the network is organized into clusters. The cluster members send sensing data to the cluster head directly. So with the clustering range RC, that is a clustering range of RC, and the CH forward packets to the sink via mutual multi-hop result, so intercluster ranging of the RT. So the connectivity problem discussed in this paper, so focus on the connectivity among the cluster heads. Every node has maximum transmission range denoted by Rmax. So this motivates the requirement of keeping network connectivity there with the limitation of Rmax. The critical transmission range, that is a CTR, is less than Rmax. The CTR is defined as the length of the longest edge of the Euclidean minimum spanning tree. So build on the nodes. If this assumption is not satisfied, the network will be doomed into connected even if every node is selected the cluster head and use its maximum radio power of data transmission. So this assumption can be satisfied by reasonable noding deployments. So at first in the cluster head selection, we evaluate how does the cluster range assignment impact the intercluster topology. The length of each cluster heads is used for measuring to measure the intercluster topology. Each simulation runs 50 times with different node deployments. At each deployment, the protocol runs 20 rounds for selecting different set of cluster heads. So when RC grows from 20 to 70 m in BSC, that is the BSC is the average LH grows 24.92 up to 79.56. So these are the distance between the node I and J. So in this JCR protocol, which can generate connected to the efficient intercluster topology. Specifically, the design goals are the clustering and routing are hybrid. So that is after executing the JCR, each node is either cluster head or a cluster member, and it has selected a node as its next hop node. So the LEH should be well controlled to ensure both the energy efficiency and network connectivity with the constraint of maximum transmission range of Rmax. The algorithm should be completely distributed with the lower end of the JCR protocol description. So finally, it's achieved the maximum network lifetime. Nevertheless, there is a performance analysis. So the JCR protocol organizes the network into cluster whose size is determined by the clustering range, that is the RC, and the cluster head uses the transmission range, that's the RT, to forward its data according to the welfare of the result obtained to minimize the energy consumption. Every cluster head should use the maximum transmission range for intercluster communication. We join the consideration of the network connectivity. The value of RC and RT should be constrained by the RC is which is less than or equal to RT, so that is equal to the Rmax. Finally, the graph or plotter, so the network lifetime comparison of the JCR and the BSC for similarly for all the graphs, so clustering range and network lifetime, and then related to the network lifetime waiting parameter in the back of timer. So compared to all the results, our JCR algorithm is best. So these are the flow diagram of the product. Yeah, let us know about the running procedure for the product. So select the main file and run. So there are many outputs on display. So these are all the outputs related to our flow diagram. So in this output, we find the cluster heads and clusters and also a routing path of the design. So in this design, all the cluster heads is designing upon in the green. So there is a green color in the system model, and the cluster heads are selected by the end of the base station. So in this base station, there are many cluster heads on display. So in this figure, yeah, first of all, these are the graph of the product. So first, yeah, this is the first figure. In this first figure, this is the base station. So in this base station, the area is 0 to 150. Similarly for the 0 to 150. So these are the clusters. So green colors are randomly selected the clusters. So these are the first of all the system model. So this is the next figure. In this next figure, the cluster formation in round 1. There are 9 number of rounds for executing the for loop. So these are the clusters connected between the base station, and these are the blue lines are indicated in the routing path. So similarly, the y-axis depend upon the 0 to 150, that is the area, and for x-axis depending upon the 0 to 150, that is also depending upon the area. Similarly, these are also the same, the cluster formation in round 2. Up to the 9 rounds that are forming the cluster and cluster heads and the routing path. So this is the base station, and these are the clusters, and these are the routing paths. So these are a similar graph up to the round in 9. Yeah, this is the next figure. In this next figure, the length of the edge among the cluster heads, that is the LEH. So this is a cluster ranging, and this is upon the length of edges among in the cluster heads. So the BSC, so that is a backup strategy clustering minimum and maximum. Similarly for the JCR is a minimum and the maximum. So in this graph are plotting by the length of edge amongst the LEH. So this is the same graph for the ratio of disconnection. So the ratio of disconnection is high of the back of strategy clustering, and this is the JCR. So the JCR is the clustering range, and this is the ratio of the disconnection 0 to 90, the ratio of disconnection of the product. So in this graph, impact of alpha on network lifetime when the side length of network area, that is MS is equal to 100, 200 and 300. So this is MS, the red is denoted by M equal to 200, blue is indicated M equal to 200, and the green is indicated M equal to 300. So the waiting parameter in the backup timer is in the x-axis, and the y-axis is depending upon the network lifetime. So similarly, the impact of alpha on network lifetime and the number of nodes. So the number of nodes NS is equal to 200, 400 and 800. So the blue is indicated NS is equal to 800, and red is indicated NS is equal to 400, and black is indicated NS is equal to 200. So the waiting parameter in back of timer is 0 to 1, and the network lifetime is 200 to up to 800. So this is the Number of nodes indicated by the impact of alpha on the network lifetimes. So this is the final graph. In this final graph, network lifetime comparison with the different network area. That is the JCR R max is equal to 70, BSC no, that is R max, and BSC R max is equal to 70. So this is the network lifetime and the sign length of the network area. So these are the running procedure for the product. Thank you for listening this video.